Hi, this is Dr. Frederick. I just want to review some concepts for weeks 1 and 2. And basically, for a set of data, and these would be our data for 19 students that we have. We asked the students how much did they sleep the night before, rounding up to the nearest hour. So we have whole numbers here from 3 to 9. And we can summarize these data in many ways. We can summarize the central tendency of the data by using the mean, the median, or the mode. And we can summarize the dispersion of the data by using the standard deviation or the range. Now, these numbers are actual numbers. These are quantities. And any of these values work for quantities. If they were something other than quantities, real numbers, then we couldn't use the mean and the standard deviation. The mean and the standard deviation always depend on having real numbers that you can add, subtract, multiply, divide, that sort of thing. And so it's important to understand the restrictions. But these data are quantitative, and so that's the first thing you ask yourself, do I have quantitative data? Now, in the exercise where we're looking at times to touch squares, you get seconds or milliseconds, and those values are quantities. So we can use the mean, the median, the mode, the standard deviation, or the range. Now, there's some characteristics of these values that are important to understand. And the main idea of our exercises recently is that the mean and the standard deviation depend on every value in the data set. If we change any one value in the data set, the mean and the standard deviation will change. But it's not true for the median, the mode, or the range that a value will always change as the data changes. And so these values here, mean and standard deviation, contain a lot of information. And these are the standard values that we use in statistical analysis. We use the median, the mode, and the range, but they are not as meaningful in most cases as the mean and the standard deviation. Sometimes it's a problem for the mean and standard deviation to be so sensitive to changes in the data, and it really distorts what we're interested in knowing about. And I'll show you an example in a second, but first of all, let's just look at hours slept. And so here, if you add up these 19 values and divide by 19, hold on a second. Let's get rid of this. And divide by 19, you're going to get this value 6.6. If you order the values from smallest to largest, the middle value is the median, right here. And if you say which value occurs most frequently, well, it's going to be 7. 7 occurs 6 times. 6 students said they slept 7 hours. Now, one student says, well, I really slept 6 hours. And the mode changes because now we have 6 students who slept 6 hours. But the mode changes. The median did not change. And let's just fix the mean here so that you can make sure that it does change. Let's just take it out like that so you can see. Let's turn that back to a 7. And you see the mean change. Alright, so let's change 2 students' values, and now we have a different median, a different mode, and a different mean. Okay, so let's put them back. Okay, and what if we change this 4? This 3 to a 4 student says, well, I really slept. I didn't know I was supposed to round up. I rounded down and slept 4 hours. The mean changes. Let's go back up and look. the standard deviation changes as well. The range changes. Okay, the range is the difference between the largest value and the smallest value in your data set. So here, those change. But what if a student says, well, I really slept 4 hours and not 5? The range doesn't change even though the standard deviation does. Okay, the standard deviation and mean change no matter what values you change. Now, in the exercise you have this week, one of the things you want to do is to get the middle value correct, the median. And now let's look at what you have this week. This week you have an even number of cases. And what is the median when you have an even number? Well, that's not the middle. Okay, it's you find the two middle values. And in 18 cases, that would be number 9 and number 10. And then you take the values here, add them, divide by 2, and get the average. Here, the median is going to be 7. And if this was a 6, we see that the median becomes 6.5. All right, so you can, I'll put this data set out for you. You can play around with it and see how things change. Or you can make your own. This wasn't hard to do, okay? And I just think I wanted to tell you something else. Oh, let's take the example of houses. And let's just take house values. We ask the students, what is the value of the home that they live in? Okay. And we'll just say it's 20 times how many hours they slept last night. 20,000 times the number of hours they slept. Okay, so let's copy that. So our students live in homes that have values from 60,000 to 160,000. Okay. Now, if you want to sort of move into the neighborhood where all these students live, you just want to sort of know what a home value is, what a home's going to cost you. You say, well, a home's going to cost me $140,000. You're going to stay away from the extremes, and you're going to stay away from the ends. About $140,000. That's the median. Okay, so let's make another table here, and these are just formulas that I have. I'll just grab the data here, put a little parentheses, okay, and we'll change that in a second. Change the median. And change the mode. Okay, let's make these values a little more understandable. Okay, so now we have our home values here. And what if you ever read a newspaper article or an internet article about home values, you almost never find that they report the mean values of homes. Now here, it says the mean value of homes is 131,000, but you're probably not going to get a home for 131,000. That would be in this range. What's happening is this 60,000 is pulling it down. Let's say that you have some enterprising students who start to take houses and flip them, and they make them very nice. Maybe they go in and gut them, and they end up with some homes that are really nice. Well, look what happened to the mean here. The mean value went to 154,000. Let's make that 450 as well to sort of exaggerate this difference. If you go with the mean, you'll believe that most homes in that range, let's say that 140,000 is as much as you can afford. Well, it turns out you could afford almost all of the homes, a sizable majority of them. But if you think if you go by the mean value, 162,000, you say I can't move to that neighborhood. But what's happening is because the mean uses every value in the data set, it's overly influenced as a predictor for you by the extreme values. And so when we talk about home prices, we're interested in median. We might be interested in modal. What do most homes sell for? That's what I really want to know. I don't care about the fat cats, on the other side of the track there. What am I probably going to pay for a house? I'm not going to pay 162. Most homes I find in that area are going to be in my price range. And so here the mean, which did take into account every piece of data, was overly influenced by the extreme values for a type of prediction that we were interested in. We're really interested in predictions from these measures of central tendency. What am I likely to pay for a house? Okay, we'll make a data set like this, or I'll post this data set and you can play around with it. Thanks.